Good afternoon. This is the Kinetics tutorial question 7c, which I did not manage to go through. Okay, so I'll briefly talk about it here. Okay, this question wants you to suggest the mechanism for a reaction that involves NO plus F2. They give you the rate equation, and they also mention that in one of the steps, two products are given out, NO2 and F radical. Okay, I think the F radical is probably something that you feel uncomfortable with. Okay, what really is a F radical? F radical, if we look at it, it has an unpaired electron. Okay, and we know that F itself has 7 valence electrons, and if we were to draw the other valence electrons, you realize that F radical is none other than a fluorine atom, right? But normally we do not see fluorine atoms as a species. Most of the time you see fluorine molecules. Okay, so fluorine atom itself is very reactive. Okay, so given all this context, the rate equation and the products in one of the steps, okay, you're supposed to propose a two-steps mechanism. So how to start off with? Okay, you probably can start off with the rate equation. Okay, looking at the two species in the rate equation. NO plus F2. Right. We know that these two reactants will be in the slow step. May not be in the first step, may not be in second step, but we know that definitely NO and F2 will be in the slow step. Okay, let's try NO and F2. We have to suggest the product. We can try this one first, okay? Because a proposing mechanism, at the end of the day, the method is still trial and error. Okay, so let's try ONF plus F dot. Okay, does it balance off? Yes, it balances off. Okay, and we know that F dot is very reactive. So F dot has to be something that is being produced and gets reacted. So very likely this F dot is an intermediate that's produced in step 1 and it's going to be used up in step 2. Okay, so let's try F dot plus something that will give me the product. Okay, we know that at the end of the day, in my overall equation, I have two ONF. Okay, one of the ONF is already produced, so likely the second product will also be ONF. Okay, the product in step 2. So F dot plus, I know that there's another NO that's not used. Okay, so does it balance? Yes, it's balanced. F dot plus NO give me O and F. Alright, now to verify that these two steps are the correct one, I form the full equation. Okay, so I form back the full equation. In my reactants, I have 1 NO, 2 NO. Okay, I've got 2 NO, 1 NO, 2 NO, and I have a F2. My F dot is an intermediate, produced and reacted, and in my product I want ONF, 2 ONF. Alright, so it fulfills my overall equation. Therefore, these two steps are reasonable steps in the mechanism. Okay, and this is the slow step. Alright, to justify my answer, okay, this part 2 here mainly want to ask you, why do we consider step 1 as the slow step? Of course, we know that the rate equations, it corresponds, right, to the slow step. Okay, but if we look at the energy energetically, why would step 1 be slow? Slow means that it needs more energy. That means the activation energy is higher. Okay, I think the reason is quite simple. Okay, in the first step, you see that there's a formation of F dot, which means that there is a breaking of the FF bond, right? There's a breaking of the FF bond, energy is needed. In the second step, there is no breaking of bonds. Instead, there's forming of bonds, and we are also reacting away something which is very reactive. So it's reasonable that step 2 is the fast step, which requires lower activation energy. Okay, so step 1 is a slow step because there's breaking of the FF bond, and step 2 is fast because we have two highly reactive species reacting together. Okay, don't bother about this. Not very correct point. Okay, so these are the two reasons to justify why I would propose step 1 as a slow and step 2 as a fast.